Hey, my name's Tyler Lynch. I'm a Senior Solutions Architect for AWS. I focus on enterprise EdTech customers as my day job, but as my passion, I contribute to Terraform on AWS's behalf. And I've been doing this for about a year now or so.
Hi, I'm Drew Mullen. I'm with AWS Professional Services. I got started recently, last year, contributing to the Terraform provider after I found an issue. We're posting about it in a Slack chat, and actually Tyler messaged me and said, hey, would you like to learn how to fix that yourself? And thus began this relationship. So today we're going to talk to you a little bit about strictly basics. What is Terraform and how does it relate to the provider? What is the provider? We're going to talk about how both Tyler and I, how we got started, hopefully how you can get started, some tips. We'll also talk about the anatomy of a contribution, what goes into your pull request, what should you expect, what kinds of files you have to change. We'll also look at a PR that has changes. So one of the more common types of updates that you can make to the Terraform provider, we'll review some code changes. And then we'll also talk about what's the pull request lifecycle like and what should you expect, whether you're new to open source or whether you've been working in open source for a while.
And we'll leave the last 10 minutes for questions and answers. So if you have questions, write them down. Feel free to throw them at us. We'll answer anything that we can.
So Terraform is an infrastructure as code tool. It allows you to declaratively provide configurations for resources that you want to build. A lot of people think of it as just building cloud resources, but Terraform can really wrap any API. So one of the infamous providers that you may know about is the Domino's provider. So somebody actually went out and wrote a Terraform provider so that you can order a pizza using Terraform. So it's not just for cloud infrastructure. It could be used for literally any API. So who here has used Terraform before? Show of hands. OK, so a little bit more than half. That's good. So we won't dig too much into the basics usage, but just so we get grounded, we have the same jargon. Let's examine one resource. So Terraform expresses resources in HCL. At the top, we have the type of resource and then the name. Those of you who have created an AWS instance before with Terraform, you know that the name web is not actually what you name your instance. That's the metadata name that gets added to the state file. Each resource type has attributes. These attributes allow you to express the nuance of the configuration that you're trying to achieve. What's your declared state? What's the AMI type? What's the instance type? That sort of thing. All resources have these attributes. We'll see where those get added to the backend in a minute. But the overall question that we want to talk about today is where does the AWS instance resource type come from? Well, it comes from the backend, which is called the provider, which is written in Golang. If you haven't written Golang before, don't be afraid. I didn't either before we started writing these resources. And so you can follow a lot of the conventions in the provider, but we're going to look at today how do these fit into the Terraform tool in general, and how can you start making your own?
So when we think about the provider for Terraform, I want to dive into what it provides and kind of how it works. So infrastructure is code, declarative language, you define what you want to have, and it creates it. Terraform core actually parses those files out. It will understand what's there. It'll validate the syntax that the user provides. It will also build a dependency graph. So it will interrogate which resources are related, and it'll create them sequentially or concurrently, depending on how they're aligned. All that's handled for you by Terraform core. And the Terraform provider supports about 200 AWS services today. So all the ones you know and love, Amazon EC2, Amazon S3. Drew and I added some storage gateway, FSX. I added Connect this week, so Connect is now available in Terraform. And so it's ever growing and it's expanding, and that's a lot of community contributions. The provider actually plugs in to Terraform core. Oh, there we go. So the provider is a Golang file that plugs in, using a plugin interface, to Terraform core. This is where you specify your CRUD operations, create, read, updates, deletes, where you specify a schema for the resource, and we'll show you what that looks like in a minute. Helper functions, and really what we're doing is we are taking data that's coming from your configuration that's passed to us in a data structure, we're unmarshalling it, and we're calling AWS APIs. More importantly, Terraform provider can actually do complex operations that you normally couldn't do. So think storage gateway can join a domain, can add an EBS volume and expose it as a cache. So complex sequential operations are totally doable with inside the provider. That makes the user's life very easy. So real quick, when you look in the Go code on the left-hand side, you see a schema, and the right-hand side is an API. An important concept is these are analogous. They're almost one-to-one mappings. All the newer resources are one-to-one. Some of the older ones, like S3, are not. S3 is getting refactored in Terraform Provider v4 that's coming out in the near future. But you see account ID and you see service principal. Those are directly related to API attributes as well. You see account ID, service principal. In this case, they're both strings. They're both required. And there's some validation getting done. And that validation is directly driven off what the API's documentation says. One thing to note is one of these says force new. Well, if you were to change account ID, it's actually going to tear down that resource and build a brand new one versus updating it. Terraform Provider allows you to do updates as well as create, depending on how the APIs are defined.
Some stats on the provider from GitHub. There's about 1,900 contributors, so you can see that this is a free and open source tool that relies heavily on community contributions. And that's where you come in, and that's where we come in. Of the merged PRs that we have listed here, you've got new services, features, and even small PRs like documentation updates or maybe minor bug fixes. Any kind of contribution is helpful for the overall quality of the tool. And there's a very high release velocity. You can see we've got over 200 releases so far. This is maintainable via mechanisms that are built into the repository. So there's good code hygiene that you would expect out of a high-quality open source tool, like linting, required acceptance tests, and a really robust peer review process. Also, contrary to popular belief, AWS does not actually own the provider repository. That is owned by HashiCorp. So we go through the same process that all of y'all will when you start contributing as well. So origin stories are always fun, so I'll leave it to Tyler to talk to you about how he actually got started.
Yeah, so for me, it started with customer obsession. My customer, I work in ed tech, COVID happened. They have a virtual classroom technology. Millions of students use it. But they had a 4,800 increase in usage year over year. 4,800% increase. Dramatic scale. We got through that, right? But as we came on the tail end of that, we said, well, how do we cost optimize this workload while still meeting the availability needs and the resiliency that we designed, especially for virtual classrooms? They figure that's core mission. We must do it. And so we started looking at Spot. Spot allows you to buy unused, unallocated EC2 instances from us at very steeply discounted rates. So we implemented Spot for them, and they have thousands of instances running in this fleet around the world in 5 different regions. So Spot dramatically helped reduce their cost. But we could only get to about 30% of their fleet running on Spot because Spot gives you a 2-minute interruption notice. If someone wants that instance and you can get interrupted, what do? You migrate your workload to on-demand or to another Spot instance. For this customer, they had very large classrooms, and they could not migrate a class within 2 minutes. So when this feature was announced on November 4th, called Capacity Rebalance, it actually gives you a proactive notification when your instance is at risk for being interrupted, up to 10 minutes. So now we had lots of room to play with, right? That's 5 times the amount of time that we could migrate that session to an on-demand server. And so the lead engineer said, this sounds really interesting on Slack. I think this would allow us to really push up Spot, maybe an extra 10%, 15%. When you're running thousands of instances concurrently, all the time, 24 hours a day, because those classes are moving around the world, this matters. And so I said, well, let's do it. Go ahead, add it to your CloudFormation. They're like, we don't use CloudFormation. We use Terraform. I was like, oh. So I went to go look, and somebody had reported an issue on the Terraform GitHub, but it wasn't supported yet. So I thought to myself, well, what would it take to actually support this? Can I do it? I'm a software engineer by trade. I've been doing this for about 20 years, but I've never written Golang. And so that was the journey I sought out for, as to help my customer reduce their costs and meet their availability needs, and try something new. Before you take on contributing to any open source software, I would recommend you research your corporate OSS policy, so open source policy. Does your employer allow you to contribute on their behalf? Do you have to do it on your own time, on your own hardware, on your own laptop? For me as an AWS employee, I'm allowed to contribute to open source software that meets certain licensing guidelines, and it's perfectly acceptable. Actually encouraged in my case. But check your employer's policy before you go do this. The first thing I did is I went and looked at some pull requests that got merged. What actually goes into adding a feature to Terraform? I had no idea. I had used Terraform, but I'd never popped open the code. I'd never used Go. And so I got to go look at things that have been merged, what kind of files are changed, what's included normally, what's the feedback look like? Is there like this online toxic culture that I don't want any part of? I wanted to know. I also started looking for the cultural norms in the code. So tabs versus spaces. Hint, it's both, depending on where you are in the code, but it actually makes sense. So concatenated strings use spaces internally. In the Go provider, the Golang code is all tabs. What about conditional logic? Is that done consistently? Error handling, is that done consistently? Yes, yes, and yes. And so I just dove through to understand how do people write the code, what's consistent, and understand those patterns a little bit before I decided to take this on. I wanted to know the scope before I committed to my boss that I was going to go dedicate some time to this. And I certainly didn't commit to my customer. My customer had no idea I was doing this on their behalf. I wanted to surprise them and see if I could actually do it.
So if you're new to open source, the contribution process looks pretty similar across the board. So you can take this model and basically apply it to any open source tool. But with Terraform, everything begins with a GitHub issue. So say you find an enhancement that you want to make, or you find a bug or something like that. The first thing you should do is go to the GitHub repository, check out the provider issues, see if something exists already. If it does, and you feel like trying to fix yourself, go ahead and claim it. Just put a comment on there, hey, I'm going to work on this a little bit. This just gives the community a heads up and allows people to look forward to your potential PR. If an issue doesn't exist, go ahead and create one. And when you're creating it, make sure that you include details, include links to the API documentation, and also potentially include examples of what the HCL changes might look like. Is this just a simple string that you're adding to an existing resource? Is this a complex block, something like that? Just try to describe it in HCL, and that will also give you some feedback. You might maybe, and when you're doing that, don't feel like you have to get it right the first time. If this is your first PR, then just take a swag at what you think the structure might look like in HCL and rely on the community feedback to help you design that and improve it.
Yeah, the mechanisms are really strong when you make a pull request to make sure you're adhering to best practices, guidelines, and the user experience of Terraform practitioners. So I would say just go do it, gather some feedback. Don't let perfect be the impediment to you getting started.
Yeah. Then after you create your issue, go ahead and fork the main repository. When you're naming your branch, they do have naming guidelines. It's pretty simple. Typically, a branch would start with the letter F for feature or D for documentation, the name of the resource, and then maybe the nature of your change. And then go ahead and start making your code changes. We'll walk through an example change in a few minutes so you can see what that might look like. And make sure that you add additional acceptance tests, whether you're adding an entirely new test or whether you're just appending your resource, your new parameter or something like that to the existing changes. And make sure that you run all the acceptance tests that exist, because we've found in the past before that sometimes making changes or adding something new can introduce regressions, and you want to make sure that you catch that before you open your pull request. Then go ahead, open your PR. I usually prefix it with WIP, work in progress. This lets everyone know that this is a draft PR, and when you're ready for review, you can remove the WIP. Get ready for community feedback. The community is very active. Many of the services have community maintainers, so people that don't directly work for Hashi, but actually are sort of pseudo-responsible for major services. And then also you can expect feedback from the Hashi team before your PR is merged. And then at that point, address the feedback that comes to you. Try to be open-minded about it, especially if you're new. Don't feel threatened by people offering you advice, or hey, you could use an enumeration instead of a static value here or something like that. Just be open to the feedback that comes.
And then we merge it.
And then we merge.
Like magic. Not exactly. So let's talk about how you can get started. For us, it was customer obsession. Has anybody here ever tried to do something in Terraform and realized that this feature does not exist? Anybody? Have you ever thought about contributing yourself to that feature? Okay, a couple, yeah, awesome.
Or wished you could.
Or wished you could.
Yeah.
Anybody can. I was super intimidated. And this leads me to talk about where I was and what stopped me from doing it initially. I was worried. I had never written Golang before in my life. I'd never even seen Golang. I'd heard about it. I know it was compiled. I know it's not interpreted, but that's pretty much all I knew, right? I know it came out of Google. Then I'm like, everybody uses Terraform. I'm not good enough to contribute to something that so many people use on such a broad scale. You know, many companies base their infrastructure completely on Terraform. And that scared me, honestly. And so am I good enough to actually do this? Then I went through all these what ifs. What if my code breaks? What if it breaks somebody's production workload? What if I can't figure it out? What if I get partway done and don't finish it? And these were just barriers to self, right? Saying like, I can't do it. And what I realized at the end of the day is I can just take a swag at it and I can try, and I know when to ask for help. And that's what I did. I have a friend at AWS. I said, hey, I can't figure out this conditional logic. Can you help me? We did a chime room. We showed everything was just fine. But I really had to overcome the emotional burden of contributing to something like Terraform and upstream before I could write a line of code. So let's run through the anatomy of contribution. We'll start with, always starts with the GitHub issue. What's interesting with Terraform and the way that they prioritize issues, it's based on thumbs up. So community engagement. If you go and you see an issue that's not there, or that's there, and it hasn't been worked on or it hasn't been merged, please add your thumb up. Crowdsource thumbs up. Go onto your Slack channel. Ask everybody to go thumb up the issue that you care about. This is a major point of how they prioritize looking and working and merging. And a lot of people don't know that. So you find if it's been created or not. If not, you do it yourself. Make sure you plus that issue. And when you're creating that issue, add descriptions, if it's new or in addition to an existing resource, sample HCL, and then references such as AWS announcements or API docs. There are plenty of issues out there that you can go. They've got a great template. The more rich the issue is as far as content goes, and the more clear it is, the more likely somebody is to pick it up or even offer to help pair up with you and do it together.
So we're going to start actually digging into contributions, what types there are, and then we'll start looking at some code examples. So there are different types of contributions that you can make, starting with the largest, which is a service contribution. This is a grouping of resources, so not just an S3 bucket, but S3 in general. Implementing the service requires the resources as well as some integrations to the provider itself. We're not going to focus on that today because that's a large task that you might start doing once you're a lot more familiar with the provider. Next is adding a simple resource, or a single resource rather. Resources, we've already reviewed what those are. Data sources are basically just, they're usually like an HTTP GET to the API, so retrieving some data that you can later use in another Terraform resource. There's always acceptance tests in pretty much every change that you're going to make. Then you'll always want to add documentation changes. We'll review what that process looks like and where those files are. You'll usually have a changelog entry. We'll see how those kind of work in to the code base and how they're used when they do their release notes. And you'll also often have helper files, especially if you're doing a resource. Let's say you have shared functions for finding your resource, and maybe you have to call that multiple times. Instead of having it several times in your code base, we usually add those in a helper file.
And one thing to note, depending on the change type you're making, not all of these files need to get modified. If you're adding an attribute to an existing resource, you're going to modify the resource, maybe the data source, and then the acceptance tests and the documentation, and maybe the changelog, depending on what it is. So it really depends on how much you're adding and what type of thing. If it's a service, a resource, an attribute, or you're fixing a bug. Oftentimes, people make documentation updates. I feel like Terraform's documentations and their examples are stellar. I feel like they're really the gold standard for being able to go find something, not just for that service, but other services that it interacts with. If you've been doing something in Terraform and you thought it was really cool, make a pull request to the docs. Add it to the examples. Let other people share that knowledge with you. And that's a great way, low friction, and a quick way to get merged and to be shown as a contributor into that repo.
So the example, and probably the most common thing in Terraform, is resources. So let's look at the structure of the file. This is common across every file. So what you're going to see, you can expect to see the exact same format in every single Terraform resource. So everything starts with the schema. The schema is essentially the skeleton of the resource. This is where you define your CRUD operations, and then also the attributes that can be added. We're going to look at an example of that, and so that you can start seeing what the actual code looks like very soon. Then you always have the create function after that. The create function has the logic inside so that you can make the Go SDK call to actually create the resource according to the parameters that you set in HCL. Next, we have a read function. The read function is used to refresh the state of your resource. So after it's been built, setting the initial values that go into your state file, but then also refreshing them every time you run Terraform apply after that. Then, fun fact, you usually have an update function, but not always. Typically, the update function is used whenever there's a difference between your HCL and when there's a difference detected between your HCL and what comes back from the read function. And then finally, you have the delete function. The delete function usually just deletes the resource and then waits to make sure that the resource has actually been deleted before allowing the Terraform core to go on to the next resource. Quick overview of the acceptance test that you'll typically find. So whenever acceptance tests in Terraform are baking real resources. These are actually, you provide your, when you're running your test, you provide it with actual AWS credentials, and it takes your code configuration, goes, builds them, tests them, and then tries to run a destroy. So typically the types of acceptance tests that you'll see is what we call the basic test. The basic test is build your resource with all the default values that come from your schema, make sure that those default values come back from the API as you expected, and then delete it and make sure that it deletes. Another test that you'll commonly see is with the optional attributes. So every type of configuration option that you can add to your resource, we want to test all of those. And you want to have acceptance tests for coverage of all those different attributes. Another very common one that's not necessarily, not always something you might expect is what we call the disappears. Disappears is when you have some sort of implicit dependency upon a resource. So for example, an AWS instance cannot exist without a VPC. So that's a hard dependency and isn't in disappears. But what might be is AWS instance that requires like a AD resource or something like that. What happens to your AD instance if the or what happens to your instance if the AD disappears? That's a type of disappear. And then usually you'll have acceptance tests for tags as well.
It's important to note that when I'm working and adding something to Terraform, the majority of my time is on acceptance tests. If I was to divide that time continuum up, it's on building clean, clear acceptance tests that account for all the different permutations that this could be used for. So in Storage Gateway, can use an existing Active Directory, can use a bunch of different things for identity. And okay, well, I have to go add acceptance tests for each one of those and make sure they work. And I want that to be clean and clear. We want to support all the different use cases. So I actually get through my HCL, like schema, CRUD operations pretty quick. Then I spend a ton of time thinking about how would users use this and baking it into acceptance tests and really rounding those out. So pull requests and community feedback is a place where I also spend a lot of time. I often think, I wrote my code, it runs, 100% test pass, I make a pull request, and they're going to merge it. That's just not the case. So when you go to make a pull request, verify the name of your branch. It's super informative for people that want to provide feedback. If it is named incorrectly, they wouldn't realize maybe you're adding a new resource or a feature to a resource. Most importantly, what resource it is, right? So some people are going to be very interested in Amazon Connect or Amazon S3, but don't care about Storage Gateway. So the naming convention really helps people identify what it is so they can go provide feedback on it. You're also supposed to run the acceptance test, not just the ones you wrote, but all of the ones for that service to make sure there's no regression across the service. I'm guilty of breaking multiple things across multiple services on what I thought were small changes. They also want you to run Terraformat, which runs a linter against the HCL code that's embedded into your acceptance test to verify it meets the requirements, tabs versus spaces, and that kind of stuff. Opening the pull request with work in progress, as you said, is super important. That signals that I am ready to have a pull request, I'm ready to have some review and community feedback, and you're open to it. Then you create a changelog update, which gets done after you make the initial pull request. The changelog updates, the file name is the number of the pull request, so you must create a pull request before you create a changelog update. That was confusing to me, but it makes sense. They actually aggregate all those up automatically to create a changelog. And then I remove the work in progress. So that's the normal process I go through. There is a full detailed checklist on GitHub under the contributors markdown click on making a pull request. They literally have a checklist of all the things you should be looking for that they're going to do in a code review and on a merge review. Like I said earlier, be open to feedback. I didn't know what I was doing. I knew I didn't know what I was doing, and I was totally open to feedback. And there were things like, hey, your conditional logic's wrong. I come from a C#, TypeScript, JavaScript, all things but Go, and the way you actually structure your code is vastly different. In Go, you make a function call, you check for an error condition, and you exit out immediately. Versus when I'm in C#, I make an API call, I look for the result, and I will catch and throw at the bottom. So it's different, and there are Go idioms. And so that feedback came to me very clearly and very consistently in a positive way. So just be open to the feedback that you might get. You might be restructuring your code to meet the cultural norms of the code base, but that's fine. There's also best practices that I didn't realize, such as use dry principles, don't repeat yourself. Use a finder. If you find yourself looking for services by maybe name, not ID or by ARN, there's a method you put it in this thing called a finder. Also, your enumerations, your errors, when you're introspecting Go SDK errors to get to the internal errors, there's a way to do that. And so you'll get feedback on best practices. So what you have might functionally work, but they might ask you for changes. And be patient. It's a very, very active community with a high velocity of change, not just in Terraform core, but in the AWS provider for Terraform. And so you might be ready for that merge. You might need that merge to go out. You told your Scrum Master, I got the code done, it's out, we'll have this ready by Monday. That is often not the case, right? At a high velocity of change and high quality releases, those two things kind of combat each other. And so HashiCorp makes no guarantees on how fast they can do a review. What they will say is if it's on their roadmap, and that's a 3-month roadmap, they will get to it during that cycle. But it's active and it's moving very quick. Speaking of timelines vary for pull requests. So I'll go over one example, the one that I talked about earlier with capacity rebalance and what that was like for me. So the feature was announced on November 4th. I had my introspection, midlife crisis, mental breakdown on the 5th, said, can I do this? I talked to AWS legal and PR and the open source team on the 6th and said, can I work on this? And they said, absolutely, that's totally fine. And then on the 7th, I started working on the code. And I did a lot of introspection throughout the code, like what am I working on? Between the 7th and the 9th, I got a lot of that code ready. Then I had to write acceptance tests. That took 2 more full days because I didn't know what I was doing, but I got it done. And so I made a pull request on the 11th. I'm like, I am done. This is awesome. Woohoo! Victory lap. Yeah, no. So many requests for change. As a matter of fact, there were 21 requests for change, 12 requests for change after I made a pull request. Those are really commits. There was a lot more changes than that. I didn't know what I didn't know, and there we are. The last change that was made was on November 18th. It was reviewed, accepted by HashiCorp, and it was merged and released on the 25th. So that's 21 days from feature announcement to release. This is common for some things, but not common for many others. There's often times when there's a pull request that's been made, but it has not a whole lot of community support or wanting with thumbs up, and so it sits there. It really depends on is on the roadmap and how much customer demand is it. So I can't stress enough the importance of a thumbs up on the GitHub issue and the pull request respectively.
All right, let's dig into a code example. So here we have a GitHub issue that was opened by someone in the community. It's requesting the performance insight retention period to be added to the RDS cluster instance. So we have a pre-existing resource. We want to add a parameter that's already in the API, or at least we're going to check to make sure that's in the API. And in the issue, they call out that it already exists in the AWS DB instance, which is nice. When you're seeing things like this, hey, maybe I have an example that I can go take a look at. I did want to call out, too, that if you notice, this is actually still an open issue. This PR hasn't been merged, so just a disclaimer that something could change if you go find this PR in the future. But it was a simple example, and it was easy for this presentation purpose. So the first thing that I usually do is go look at the API. If you don't know what the call is to the API in this example, it's actually pretty easy because you can just look into the Go code because the resource already exists. So I did that. And I actually found that it's calling the createDB instance. So I went and I looked at the API. And then I looked to see, does this parameter that's being requested exist in the API? Looking at the API documentation is helpful because it tells you what should you name this parameter, because we want to be one-to-one with the actual AWS API. It gives you a good description for your documentation. It tells you which values are valid for this parameter. So some attributes have hard limits on what you can actually put in there. That's what the valid values are. And then it also tells you whether it's optional and the type. So this is type integer. So in this change, just to review, there's 4 files that we're going to look at that were actually changed. The first is the resource file. I want you to look and see that resources are located in the repository root under the AWS directory. So AWS / then the resource name. That's where you can find all the resources, all the data sources for the provider. We're going to take a look at that file in just a minute. Next are the tests. The resource tests are always named the resource _ test. Next, we have the documentation. One thing that I wanted to call out here is there's in the root of the repo, there's a docs directory, and that's actually not where these docs go. The docs for the resources go in the website docs, R for resource, D for data source, and then the name. And then there's also a changelog update. So a couple things to notice about that. One, it's in the you're going to put this file in the .changelog directory. The name of your file you'll see is 2109, which matches the PR number that's up at the top right. And then also while you're looking up there, you can see that we have the branch name, which was f-RDS cluster instance. So it follows kind of the branching name patterns that we talked about earlier. All right, so now we're going to start digging into the actual files. This is in the Go resource for the actual RDS cluster instance. You can see the name at the top is RDS cluster instance. And we're looking at the schema. The schema is kind of the skeleton for the resource itself. It starts by defining the CRUD operations. These CRUD operations are actually, they're linked to actual functions in the same file, so we'll look at each of those functions. When we go through these files too, I'm going to highlight a bunch of things, but I'm also going to explicitly tell you which pieces of these files were changed. So if you look at the PR, you can see them a little bit more clearly in GitHub, but that doesn't translate super well for a presentation, so I'll just point out to you which ones we're changing. So you have the CRUD operations, then you have your schema. So this is where you define all the attributes from the API that you can accept. You'll notice that some of these are computed, so port, for example, is computed. That means that the user for this instance, for this resource, can't pass in the port. That's provided by the API call. But then the next one is required, so that's a required string for it. And then at the end here, we have the addition that we made to this file. So we're adding our attribute, performance insight retention period. It's type integer. It's optional. We give it a default. And we pass it a validate function. The validate function is what declares what's a valid value for this resource type. And if you put something else in there, the compiler kicks it back out before you're actually allowed to run Terraform apply. Next, we have the create function. This is in the same file. The create function receives the HCL code whenever Terraform core detects that you've expressed an HCL resource that's not in your state file, it fires the create function. It passes you the HCL content via the D parameter. You'll see this in every function. So we use the D parameter to retrieve from HCL or to set into the state file. We'll see examples of both of those things. The only change that we had to make to the create function here is checking whether or not our parameter performance insight retention period was passed to HCL. So you see here, get OK, check for the name of the parameter, and then if it passes that, if we get a true, then we take the value from that parameter and we add it to that map called create ops. You see create ops dot. And that create ops is then used a little bit further down the function to run the SDK call. So this is how it translates from HCL to the actual API call that gets made. It's just kind of marshaling it from HCL into this map.
And one interesting thing about AWS APIs and use of the SDK, they're backwards compatible by design. We intentionally build our SDKs and our APIs like that, so we can extend them, like add a new parameter called performance insight retention period that previous clients don't know about, don't have to submit, and we only apply it and use it if you pass it in. That allows for this extension where we can very quickly add a new option into a parameter to call create DB instance, and it gets utilized. You don't have to worry about breaking the versions and anything else. Go make sure that we have this, and we have the latest version of the SDK as we build it out.
The last thing to note on this file, sorry, just go back briefly. At the bottom, the create function and the update function always return the read function. And that can be a little confusing at first, but let me show you why that is. So in the read function, read, as I said before, is used for setting the state file and then refreshing the state for comparison. At the beginning, you almost always see a describe call. So this resource has like another function that it calls, but if you look into what comes from that DB instance retrieve function, it's really just doing a describe call. That describe call is then used to set values in your state file. The only change that we have to make to this read function is very simple. We are basically taking from the API call and setting it to the state file using d.set. And then we provide the name of the parameter that we want to set the value for. Next, we have the update function. We do have to we do have to account for an update here because this parameter is optional and it can take updates. The update function is called when Terraform core detects a difference between what's in your HCL and what comes back from the API from the read function. Then it fires update. And the update function has logic inside it to account for any changes to parameters that can be modified. Tyler mentioned that a parameter has force new. If it has force new, that means it can't take an update and you have to recreate the whole resource. The update function is the latter case where you can take an update, you can modify that resource, that parameter on a resource. There's only two changes that we have to make to this function. The first is we check to see if our parameter has a change. And then we also check what that change is, and then we add it to the REQ request map. And at the bottom, you could see that REQ gets actually passed to the modify DB instance function slightly later down in the same file. All right, so we've talked a lot about acceptance tests, but what do those look like? In my opinion, this was the most intimidating part of getting started, but I want to try and boil it down to kind of the simplest things here. Each acceptance test file can have several tests, and those tests can have several steps. These steps are the meat of where you're going to write your code here. Each of these steps basically performs or gives you the option to perform create test, then it can delete or it can leave it for future steps as well. The steps are here. Here in config is where you provide actual HCL. You can provide that via a string, const, or something like that, or here we provide it with a function. This gives it some HCL code that your test will actually go build. We also pass it the 731, which you'll see here. The next part of the step is, go ahead, is the check portion. So we configured, now we're checking. And the only change that we had to make to this whole test was actually adding in a check for our parameter. So here we're saying, check the resource attribute, performance insight retention period, and make sure that it's 731, because that's what we passed to the config portion.
And if you've done TDD or unit testing before, it's substantially similar, right? This is where you give it a configuration, and you assert that what you believe to be true is true. In this case, if you pass it 731, you want to get that back. It is abstracted a little bit from you, and they just say checks, but you're really just doing assertions. There could be multiple steps as well. So you can create a resource, you can import a resource, and you can modify a resource and verify that you are able to modify those parameters that you want. This is just a simple example that we provided here.
Then we have documentation. Documentation is essential in Terraform. If you've used the registry docs, then you know that a really good example and a really good explanation of the attribute can help a ton. So make sure that you think about this. You can see here what we have is this is an optional parameter. We note that at the beginning. And then we have a couple of lines that are essentially what comes back from the docs. That's the first two sentences, what comes from the API documentation. And then the last two sentences are explanations of dependencies between other resources, or between other attributes. So in this specific example, our retention insight period attribute relies on the performance insight enable parameter. So that has to be true. And then we also note whether there's a default. And then the mysterious changelog file that we keep talking about, this is used to aggregate changes from PRs. So every PR that's made that has a noteworthy change, you just have to add in this small file that has, we note that it's an enhancement, we note the resource that we're updating, and then the actual nature of the change. These get aggregated and go into the release notes whenever there's a new release of the provider.
So who here has a smartphone in their pocket? I thought so. I would like you to click on that, grab a photo of that, jump to it. What this is a direct link to the issues board on the GitHub repo for the AWS provider. And these are specifically issues that have been tagged by contributors and maintainers as good first issues. So these could be documentation updates or bug fixes. These are ones where we believe the barrier to entry to somebody contributing is low enough that anybody can take this on. I do recommend you pair up with a friend. But there's, I think, 25 issues last I checked. These are great to go start with. Drew and I are available. Our contact information is pretty easy to find online. Hit us up on LinkedIn. If you start on one and you're like, I don't know what to do here, I'm happy to pair up with you after hours. I would love to be able to show that and kind of scale the knowledge that we've went through to let other people contribute. Right now, I'm working with the New York Times. I'm working with Vodafone. We just collectively added Amazon Connect last week together, and we did this after hours on the weekends. And it's been almost like a hackathon for us. It's been no Red Bull, but it's definitely been lots of coffee. It's just been a wonderful way to meet new friends in the industry and to start to meet their needs as an organization in some of our off time. Anything you want to add to this first issue?
No.
All right, we'll open it for Q&A. Does anybody have a question?
In the back.
Hey, how's it going?
Hello. I'm actually giving a talk about that tomorrow, but there are multiple differences between CloudFormation and Terraform. CloudFormation is a AWS service that AWS provides. It has rollback functionality. It's declarative. Terraform is written by HashiCorp, completely separate. It uses the public-facing APIs of Amazon or other things. So Terraform can be used for other cloud providers and even on-premises. There's a bunch of stuff they do with VNC. It allows for more complex operations, like sequential operations inherently. It's really a preference. Terraform you can also not roll back on. It doesn't have support that CloudFormation does. So there are some slight differences in the way you use it and the way you think about it.
Hashi would say, too, that Terraform is for any API. So you can order a pizza from it, or you can just build resources.
I'm sorry, you had a question, sir?
Yeah, I'm not sure if the mic works, but I'll just talk loud. So for
It's working. We can hear you.
regions that aren't commercial regions like GovCloud, or if I'm trying to write a Terraform provider or add support for something on a Snowball or an Outpost, how easy it is to do that? Because there's, like a service could exist on a Snowball or in GovCloud, but it could have different features in a commercial region.
Yeah, let's talk about partitions first, then I'll get into Snowball and other things. So not every AWS service is supported in every AWS region, right? As we build out new regions, we put out new services, teams talk about, they look for customer demand before they put their services there. This is also true of partitions. You think China, GovCloud, and other secret partitions that we're not going to talk about. So services may or may not be available. If they have a public API, and if that's available, depending on where you are, US citizen, those kind of things, yes, it could be put in Terraform. Snowball becomes different. Snowball is a disconnected device. If it has a public API, you could do something. I don't know if the Snowball stuff exists there. We did add Storage Gateway, which is kind of similar, but it's the set of Storage Gateway in your AWS cloud or a VM on-prem. It does work. So if it's like Outpost, Outpost is actually seen as an extension to an existing region. It will work just fine because you use control plane in region, which has public APIs. And if you don't know, Amazon has control planes and data planes. Control planes are how we control our services. That control plane in public, in any region, will control your Outpost. And it can set up S3 and other things, instances EC2. It just marks that as the target to host it on. So it will work just fine on Outposts. I don't know about Snowball. I've never verified that myself.
One last thing to add is that there are resources for Outpost. There's somebody who internally at AWS who's worked on several of them.
Oh.
So
Interesting.
Thank you.
So right now we are working on Amazon Lex for chatbot, and it had version 1 previously, and now Amazon has version 2 for Lex. When I checked the documentation for Terraform, I wasn't sure which one is that using, and if we wanted to support both versions, how can we do that?
boy, did you ask the right guy.
Yeah, so I'm working on that later today. Amazon Lex V1 and V2, the APIs are different. This is one of the places we didn't want to break the APIs, so we provided new APIs. Terraform does support 1 and 2 today. Amazon Connect does not support linking them through Terraform yet. It will very soon. I would say go to the documentation on the Terraform registry. Look for bot. There's LexBot and there's LexBot and bot. I believe bot is all V1 and V2. It actually supports both operations on the same resource. The other one is LexBot, which is only V1. I think I have that right. Catch me after, I can go look for you, but I'm working on that this afternoon.
I asked specifically because the API calls are quite different from version 1 versus 2.
Yeah, and so they've actually separated those as separate resources. You can use whichever version you want to use in Terraform. Yep. Any other questions, friends? All right, we can give you some time back for coffee and bio breaks, but you'd appreciate that before your next session. Thank you. Let me just pull our, if you want to give our email addresses, you can email us. You can also find us on LinkedIn. I do respond to LinkedIn messages regularly. We will happily help guide you. I love to do code reviews for people, so you do something, mark it work in progress, throw it up there, tag me. I'll do a code review, absolutely.
Me too.
And the last thing is please fill out our survey. These survey scores are really important to us, and being able to speak at conferences is something we love to do. And I hope to have like a solid 5 so we can go to reInvent and talk. That's my hope.
Yeah.
So please fill out our after-session survey. Thank you, everybody.
Thanks very much.